What I want to do next is my percent error calculation. So I want to add a new sheet. So I'm going to click on the plus here, and it's going to give me a new sheet. And then I double clicked on that, and I called it percent error. Okay, then I came up here and I typed in the words experimental density, identity of item, theoretical and accepted value, and the percent error calculation. Once I type those words in, I notice I need to drag my column over and make it larger so that the words fit. Now, the experimental density, you're going to type that in. That is the slope of your line, because the slope of the line is the difference in the y value, which is the mass, divided the difference in the x value, which is the volume. So mass divided by volume gives you density. So the density, your experimental density, is this coefficient in front of the x. So for me, it is 8.09 grams per milliliter. All right, so 8.09, and I'm going to put the units grams per milliliter over here in the other column. I don't want to put anything but numbers in this column. Okay, now the identity of my item, and I'm just pretending that I'm using brass. You wrote that down. Now the theoretical or accepted value for the density, which is in grams per milliliters, that comes from a known source. So what I'm going to do is I'm going to put the theoretical values up on your Google Stream so that you can identify which one you have. But for brass, the theoretical value or accepted value is 8.5 grams per milliliter. Now down here, I want to do my percent error calculation. You did this whenever, I think you did this with Coach Mike, but the way you do percent error, it is, remember I'm going to put an equal sign here because I'm doing a formula. Have to make sure also that we put a parentheses here because we're going to subtract the, and this is also, this is on your lab handout. Okay, so this is on your lab handout. As a matter of fact, I don't even need to publish the medal because it is also on your lab handout. So you're going to get this from your lab handout for whatever you have. Okay, now I know that they put absolute value signs on your lab manual, the lab handout that I gave you, but I don't want to do that, and I'll tell you why here in a minute. Okay, so I'm going to put a parentheses, the measured value, or which is the experimental value, and I'm going to subtract that from my accepted or theoretical value. I'm going to close my parentheses, and then I'm going to divide it by my accepted value, which is that. Notice I get a negative 0.04, blah, blah, whatever. I want to change this to a percentage. So I'm going to click on that column, and I'm going to hit Format, Number. I'm going to change it to a percentage. All right. So Format, Number, and hit More Formats. And we want a percentage here. Now, the number that you have after, the number of digits that you have after the decimal is going to depend on which scale you used, okay, and how many significant figures. So you have to determine how many numbers you have past that decimal. And I'm willing to bet that that number is probably going to only be accurate to one number past the decimal. But when I apply that, I get a negative 4.8%. That means I was below the accepted value by 4.8%. That could have been because of my measuring errors. It could have been because I did not read my graduated cylinder very well. Our equipment wasn't the most accurate.